with that. Give me my pen. Where is my pen? I am checking for my pen. I kept it somewhere here. Okay, fine. First one is solid. Tell me some examples for solid. Rock. Pen, fine. Liquid. Water. I will draw H2O. We are studying chemistry, right? Only in chemistry, like H2O. In other subjects or in English or in other social or in physics or biology, it comes means write water. Okay? In chemistry, no problem. We can write H2O. Next one. Honey, oh fine, honey. Oh, honey, gas. The air we breathe. Okay, LPG, liquefied petroleum gas. Anything else? Hydrogen gas, oxygen, nitrogen, all the gaseous forms are. Water vapor, oh, that's a good example. Water vapor, I don't have space, so I will write water vapor here. So these are the three forms of matter: solid, liquid, and gas. Mostly solid means that word itself defines solid, tough, like a rock. Ouch. Don't do that at home. Next one is liquid, the water we drink. It's a bit more less denser than solid. After that comes about the gas. This is also less denser than the both solid and liquid. So, what is the property which makes these solid, liquid, and gas? What is the property? If everything is gas is matter, liquid is matter, solid is matter, then why we are writing it in three ways? We just write matter, everything finished. What is the difference between these three types of matters? Of course, properties. Their properties are different. Okay, on the basis of physical state, matter is classified into three: solid, liquid, and gas. Okay. Chemical composition, matter is classified as pure substances and mixtures. Where is my paper? Okay. According to chemical composition, okay, chemical composition, what all chemicals are involved in that matter, we can describe matter into two. That is pure and mixture. Okay, this is a bit part of chemistry. I think something new for you. This you already know. Physical. These are the three physical state of matter: solid, liquid, and gas. But if it comes to chemical, if you come to chemical composition, matter can be described as pure form and mixture form. Pure form means basically elements and all. Elements like oxygen, carbon, hydrogen. Okay, the purest form is the elemental form, and also some compounds are also there. That is the purest form of matter. Then comes the mixtures. Mixture as of two types of mixture are there. There is homogeneous mixtures and heterogeneous mixtures. These will details we will study in the coming classes. So when it comes to chemical composition, pure and mixture. When it comes to physical composition, it is solid, liquid, and gas. So pure means the purest form. For example, most of the elements, all the elements are the purest form of matter. Then some of the compounds also are purest form. But when it comes to mixture, can anybody tell an example? I tell two types of mixtures are there. Homogeneous mixture, I didn't write it in paper. Okay, let's class we will discuss about each. Homogeneous and heterogeneous. Homogeneous and heterogeneous. Homogeneous means the particles are dissolved in, so it's a mixture, right? For example, hydrogen, oxygen, what all elements are there in the air? Lots of elements are there, isn't it? Oxygen, hydrogen, come on, carbon, helium, nitrogen, inert gases, okay, all lots of gases are there. But can we spot them? Can we identify them? If I know this part, just take this part of the atmosphere. We know that it's a mixture of gases, but can we identify where is hydrogen? Can we tell hydrogen is here, oxygen is here, this is carbon dioxide? Can you tell that? No, because it's a mixture. and we cannot find out the difference between each and different elements. That type of mixtures are called as homogeneous mixtures. For example, our air, salt solution, uh, what about the next, sugar solution. If we add sugar and salt and if we mix into a water, it will dissolve, you know that. Can you look and tell which part is sweet, which part is salty? Can you do that? No. Such mixtures are called as homogeneous mixtures. And some other types of mixtures are there. For example, if you are adding oil into water, what will happen? Oil will be at the top, water will be at the bottom. Can we tell that? Where is oil? Where is water? Of course you can. Just look. Oil is upside, water is down. A lot other types, such types of mixtures are called as heterogeneous mixtures. Okay, we can identify the difference in different compounds in that mixtures. But in the case of homogeneous mixtures, we cannot identify any differences. Okay, next we can study about the physical nature of matter. Physical nature of matter. For that, we need to have one paper here. 1 second. Okay, let us see. We have one pen here. Wait. Physical nature of matter. Let us see. First one. Matter is made up of particles. Any doubts? No doubts, isn't it? There is no doubt about that. 100% all matter in the world is made up of what? Particles. I am standing here 5 feet 6 with 75 kg. If I am made up of one particle, what will happen to me? Can I move? No. I will be like a stiff man for my entire life. So, if we go in, we can see small building blocks in our body. Not only our body, wherever if you see. This concrete wall also is not a single piece. This mixture of lots of small particles. Understand? Any doubt about that? No. The building block of all the matter is called as atoms. Yes. And the particles of matter is very tiny, isn't it? Just break a piece of concrete, powder it, we can see that powder in our hand, isn't it? And if take one piece such of powder and again powder it, small particles, we can see it, a small dust, again grind it, it's gone. Where? Can you see that? No, because it is tiny. Understand? We cannot see that particles with our naked eye. So we use particular types of instrument called as the microscope. But even the atoms which we are going to study, we cannot even see that through a common microscope. That's why we are using electron microscope for that. Understand? I think in before classes you studied that atoms are very small, isn't it? But in reality, nobody has seen atoms. Nobody in this entire world has seen atoms yet. Yes, of course, it's true. Even if with electron microscope, we can only see that atom exists. Understand? Like small, tiny particles. But we are not sure. Even if with electron microscope, we are not getting clear image of these structural parts of atom. Okay, that's not our syllabus. That's not our part. Okay, it's big discussion for scientists and all. We can leave that. We can come back to our class. So another property of matter is the particles of matter have space between them. That's a tricky one, isn't it? Here we can understand that these particles or this matter is moving here and there. There is space. That's why I was able to put my hand through the air. See, my hand is stiff, so I cannot put this pen through that. If I hold like this, there is a particular space between my fingers, so I can put this pen into my hand. So particles of matter have space between them means all the matter is not closely linked with each other. Okay, some matters have space, and that space between this particle is more in air, medium in liquid, and space is very less in solid. Okay, based on the space between the particle, we can divide it into solid, liquid, and gas. Solid, the space is very less. Liquid, it is an average level, and gas, it is very high, very big space. Okay, another property is the particles of matter are continuously moving. The particles of the matter are continuously moving means what? It is moving. What is moving? Can you see that moving? No. I think it's still for me. Okay, fine. What about this air? It moves, isn't it? Okay, that also we can discuss in the next part. The particles of matter attract each other. Of course, it attracts. Let's see with a small example. See, I have a paper in my hand. Okay, I have a paper in my hand. So it's a matter. It attracts each other. When I tear, it's two pieces, isn't it? So I broken that chain of attraction. That is also other properties of matter. So according to scientists, these are the three physical nature of matter. First one is matter is made up of small particles, and the particles of matter are very tiny. And the particles of matter have space between them. Okay, they are not closely bonded, they have space between them, and that space is more in gas, average in liquid, and very less in solids. The particles of matter are continuously moving. The particles inside the matter is continuously moving. We will discuss that in another portion because it's very important about that. Can you imagine that these tiny particles inside a metal is moving? A nail, a wire, a huge hammer, these particles are moving inside. Can you believe that? But it is true. We can discuss that. We will discuss in physics part. Next, the particles of the matter attract each other. Understand? It attracts each other. That's why it becomes in particular forms. Understand? Three different forms. The attraction is very high for solid, average for liquid, and very low for gas. So that's all for today. Okay, it's only an introduction class for you about this chemistry part. It's very simple. Mostly science for 9th standard is very simple than the 10th standard. Okay, anyway, we will enjoy this class during this pandemic time called as coronavirus. So it's a global killer. It's a problem of the entire world, my dear kids. You can hear that numbers from the news and all. Day by day it is going up. It's going out of control. So the better thing you can do during this time is to stay at your home. Okay, don't come out, stay at your home. It's safe. The safest place you can be at this time is your home. Okay, leave what all things your parents says, what all order they give, just do that. Stay at home, eat very healthy food, nutritious food, drink a lot of water, and keep health and hygiene. Okay, so this is your science teacher Mithun Raj signing off from this part of the world. You can see with the next part of the same chapter.